Hello, this is Photon, back after a pretty long summer break. In the meantime, I've released a new The Player play routine because I discovered a fix for the EDX command, and also I released a crack intro of sorts for a game called Where Time Stood Still, which Galahad has converted from Atari ST. Shall we continue from where we left off? If you remember from last time, we had added some copper shades, one in the background and one made out to be a copper bar, which is currently completely behind the logo, and we colored it to a steel blue gray kind of shade with some color values. And in this tutorial then we should make the logo semi-transparent and also make this copper bar go in front of and behind the logo on each alternate turn. So let's see where we were. So for those of you who have sharp eyes, you may have noticed some crap characters before the first character appearing in the scroll text, the J character in just for the retro feeling and so on. If you're quick, you saw it. If you weren't, you missed it. And this is something we left behind, so let's clean that up. In the init part here, we had a little test thing when I demonstrated how to scroll the screen, namely to fill a lot of binary numeric values into the first bit plane of the screen, back when we only had one bit plane showing below the logo. And now this can be converted, well, what we need obviously is to clear the BSS data down here, where we started out with just taking a portion of the memory that we happened to know was free and use that for a screen buffer, but then we made it system friendly with this BSS hunk or BSS section, and now we have this many bit planes on the screen. I could pretend I don't remember how many there were, but I think it was 3, right? So, but since we have it in a variable, we don't need to know how many bit planes we need to clear, because this many bytes is what we need to clear. So we shall convert this little, well, if we enable this, you will see the original bitplane patterns in the first bitplane only. So since we are changing the bitplane pointers in the split below the logo, it bounces along with the scroll, and this is good for getting a feeling for how all this works. So that's what that did. As you noticed, I changed this to this. I could also remove these this if statement so that it's executed every time, just as with this if statement. In other assemblers and in ASM1, another way to write this is, for example, if EQ 0, because 0 is certainly equal to 0, which is what this means, or if not equal to 0, 1 or 2 or 3 or whatever is not equal to 0, you put here, then it will also run. So that's a parenthesis, just to, in case you a few users are using a different assembler to follow my tutorials, so that's a way to translate these if statements. to a more generally usable format. So anyway, we're going to remove these this conditional, and what we need to do now is to fill all 3 bit planes with 0. So obviously this could be optimized, however it's pretty quick to execute even in this very unoptimized format, and it's done before anything starts. So just for the sake of keeping it simple to understand, this is how we modify that loop. So as you can see, nothing precedes the j in just for the and so on, because we've made sure that the BSS data, which is just a chunk of memory that is allocated and that the system does nothing with, we make sure that that chunk is filled with zeros. In other words, this is a clear screen routine, if you remember the old basic etc. commands. Of course, it doesn't clear the entire screen because we have a split in the middle below the logo, so that whatever is above that split points to the logo, which is fixed and isn't modified in any way, so that it wouldn't be smart to clear the logo before showing it, would it? But in the buffers where you add stuff and scroll stuff around, then you should of course clear your BSS data. So that's that. About the new version, you could say it's nothing special, especially not if you don't swap out my module for another module that you want to use in your demo that uses some pretty special commands. But in this case, I've made sure that you can just swap out the play routine by doing this. And this is because I've unzipped the p6111 file to this directory, just as I did the previous version. So in here is the example which you should test your modules with and read the notes of, and some more stuff. So that's all you need to do to upgrade to the latest version. If you don't need to do this. If you find that your module, that you swap out the module and it doesn't play correctly, then please try this latest version. I've decided to leave this play routine for now and essentially document it well and not answer any questions about it, because I have other projects that I need to pursue. Too much talk about this. What we've done so far is just swap out the play routine and clear the screen. Nothing really has changed. And of course we're going to need to swap out the scroll text, because this will be a cutting edge demo by the time we're done. No, it won't be, but it will be a simple demonstration of how to code demos anyway. You can type anything you want in the scroll text. So the next step then is to do something about that moving copper bar behind the logo. So let's start with making it semi-transparent. And how on earth do you do that? I mean, if you look at this, it looks like a solid bar moving behind the logo. And that's because we change only the background color. Of course, everything around and behind the logo is the background color, or it wouldn't be the background color. But naturally, we can change the entire palette or close to, on each scan line with the Amiga copper. So by modifying the fill color of the logo, you can, at the appropriate weight stops in the copper, you can make it look like there is a moving bar inside the logo. So let's go ahead and do that. And of course I have no idea. I'm making this up as I go along, so I'll have to look at this bar thing here. Here we go. And these are the steel blue gray thing color values that we added. Now if I only knew what color the fill color was in the logo, I wouldn't have to guess, but I will have to guess. So by adding a color move command to color 01, the color 01 register, I can make it change the color on the first line of the copper bar. So let's just see if that was no good. Okay, we have you can't just do that because we have a loop up here. I'm lucky to get back inside the assembler. I might have had to reset my computer if I didn't get the copper back. Now if you don't get the copper back, if it's rolling like that, or if you don't get your mouse cursor back, you can try the following things. Amiga M to toggle screens, and you can pull the mouse cursor all the way up. Make sure just pull a lot up until you're at the top row, and just pull the screen down like that, because then the operating system kicks in and makes sure that you have that it shows the copper of the screen you're on. And so what happened here was that I changed the distance between these labels, but just for the first step, which means that instead of poking the next weight position there, it poked it in the color register declaration here. So that's why the copper rolled. So we will have to make the color modifications on each line and increase the step between lines. And I don't think we have to reset the color after here, because we're going a loop from here, step, 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 and done. So let's see where let's search for that label, because yeah. And that's my cat interfering with my recording. Hello cat. This is my cat Cactus, making an appearance in my video. And I've given him food and milk and all that stuff, but he seems discontent nevertheless. So what we need to do is increase the step here. So that should increase from 2 copper instructions to 3. So why not? A copper instruction is 4 bytes. So previously we had it skipped to 2 copper instructions below it. So let's increase that to 3, because now we have 1, 2, 3 instructions per step. So that should work a lot better, and we should see a permanent color change of some color in the logo. In this case, you can see that one of the anti-aliasing outline colors were affected by this color 01. So color 01 is in the outline, and the fill color then, let's guess, is color 07. So you can calculate this by taking hex 180, which is the color 00, and times plus 2 times 7, that's color 07. So that's 18E. So let's go ahead and try that color. Sorry about this, but I think we're going to strike gold here. By which I mean we're going to affect the correct color. Nope. doesn't seem to affect anything. So did we have a logo pal? Hang on. Logo pal colon. Yep, we did. So look for the red color. Should be pretty simple. That's light gray or almost white. That's the red color right there. That's almost gray, so that's an outline color. That's a red color. That's a blue color. That's a blue color for anti-aliasing to the background. So a few colors are for anti-aliasing to the red color, and a few others are for anti-aliasing to the background. As explained in a tutorial long ago, in a galaxy quite near to you. So I would say that this is the color because it has the might be this one. Two people have asked me what that my keyboard sounds nice and wondered what I'm using. I'm using an Amiga 1200 keyboard connected via the Keyra version 2 for PC adapter to my PC. But, well, it's nice to have the correct layout, but I don't mind nice PC keyboards for Amiga emulators. The only snag is you have to remap the control key and the Amiga keys, possibly. So there it is. Now you would think that we need to change two other colors as well. We might, if it doesn't look good. But my thinking was half of the time it will be in front of the logo, and half the time it will be semi-transparent, which is not so far from those two other reddish colors that you saw on the inside of the outline. So this means this is the right color, and if we just tweak this towards red, it should become semi-transparent already. So I have no way to, envision what the RGB value should be, but all I can do is, well, I could try adding some red. I'll add 3 to that. Why is this the same? Oh, okay. So that would be B90. And I'll add 3 to that, which is impossible. Hang on, I'll have to drag it down to red right here. So what I should do is take the value from the logo palette and fade that up a bit, just slightly, to make it appear to be transparent. So it's right here. I seem to have missed it before. And the color we were using was 833, so if we use this value and tweak it up, and we should tweak it up towards this blue-gray scheme, so that this would be just a few steps more blue. Again 833, but a few steps more blue, and a little bit of increasing the overall brightness of the value of the color. I mean, you should do this in Deluxe Paint. It's much easier. So I'll go 8, 4, 6. That's not enough, I feel. And here's the white color, so that should be sharp, so 833. And we still want to be red, so actually I'll try these values and see how it looks. It's of course not necessary for any type of learning how to code to put in correct RGB values, but it would be nice. It's nice if it looks nice. Well, sorta kinda. I like it. It's gonna stay. So, that's so much for the transparency. Now, every other time it changes direction, it should change whether it pokes these values or copies these values to here, right? That's the master plan for the for making it appear as going in front of or behind the logo. So we need to copy both these values to some table, some list that we pick from depending on a state or a flag or something telling us whether we are behind or in front of the logo. So let's start with that, and I'll have to I'll just copy the whole thing and reduce it to a list. And as always, I'm making this up as I go along, so probably some of you have figured out an easier way to do it, but I'm just gonna copy this straight up and down. We could even make a straight copy. I think that's what I'm gonna go for. It's a bit overkill. I mean, it's a bit wasteful. You copy the weight as well, and that could be a problem. Yeah. So I'm not gonna do that. Haha. Okay, let's do it the right way, which is to minimize the data and do a proper copying code. So these are the values, but we no longer need the actual copper register values. And we're gonna put a label here, which is called bar behind. Copy that and call this bar in front. And here's where we, when we are in front, every other value, this one was for the background color, right? And this one was for the fill color of the logo. So that this value should be 558. This value should be 9D. This should be FFF, and so on. And 558. There you go. So now we have two sets of color 00 value and color 02 value. And so on. That we need to poke at the right offsets into this depending on whether we are behind or in front. And we will know if we are behind or in front after we run the loop that pokes these weight positions. after the code that actually moves the raster bar. So again, here we go. And we did have a flag of sorts, which means that we can decide that when it's moving upwards, it should be in front, and when it's moving downwards, it should be behind. You can make it the other way around. That changes the direction of well, the illusion. So right here is where we negate this flag. So d6 contains our direction, which will be 1 or -1, and depending on its value, we should go ahead and, while we loop through these addresses and change the weight position, we should also copy the colors from the corresponding behind or in front list. You with me? Okay, so we'll compare. If it's moving downwards, if it's not, we should skip it. And in here we will have to change the default pointer to the color list that we want to copy to down here, to the actual copper list. The lists we just made are not copper lists, they're just lists of RGB values. So continuing using LEA instead of doing this can be translated to LEA, load effective address, like this. So you noticed I removed the number sign there. That's because that's the address, and when we used move, we had to tell it was an immediate address value. Otherwise it would have read that address and put its content in A0. With load effective address, this is not expected behavior, but instead what's coming here is an actual label or address. So we'll assume that it will be in front. And here we can introduce this PC relative addressing to save 2 bytes. This is new territory for us. But if you're sensitive about the size of your code, or if you want to, well, there are various reasons for making your code PC relative. For now, this means that this label must be within 32K of the address of this instruction. Tell you what, I'll introduce it later and keep it simple for now. So, and since A0 is used for this loop, we'll have to put this in some other address register. Just on a whim, I'll use A2. And otherwise, it should use bar behind. So the way that this works is, this is a runtime conditional. This is a runtime if statement, so that you start with the default source address for RGB color values. And I'm a bit sloppy pressing the space key there. And if it's moving downwards, or rather, if it's not moving downwards, then it skips this, so that when it moves downwards, it replaces this default source address with another source address to read from the other color list. So that's that. Now the A2 address is of course not being read inside this loop yet, but we can make sure that it does. So what happens here is we poke the Y position that we later increase here in the wait position part of the list. Let's put a bookmark here and go to wait 1 again and see how it looks. So it pokes this byte and then increases whatever value it put there. The A0 pointer still points to this word right here, so that we need to add 2 to get to this to get to this address. Then we need to skip 2 more bytes to get to this RGB color word, which is what we're interested in. There we're going to copy 1 word from the source address in A2, and then we're going to skip to the next instruction, which means another 2 bytes to skip over this, another 2 bytes to skip over this to get to the second RGB color word. So that it will look something like we'll poke whatever address A0 is pointing at, will increase by, let's see, 2, 4, 6, and then we'll increase by 2, 4 to get to this address. So that this offset is 6 from the A0 register, and this offset is 10 from the A0 register. So I don't remember if well, obviously I've introduced the addressing mode where you automatically increase an address register when writing to it, when poking values into it. We can't really use it for A0 here because this moves a byte, which if we add a plus here, it would increase the address by 1, and we'd have to compensate. We'd have to add to A0 anyway. Instead, I'm going to use it for the source address. The background color word, and move it to 6A0, and similarly the fill color RGB value to the fill color. I hope I didn't actually accidentally turn off recording. I think I did. Well, time will tell. Anyway, this is the modification to poke the background color. And this is to poke the fill color. And again, the space key. And by using these offsets, A0 is kept at its original position, and this step to the next wait is still correct. So let's go ahead and save. I would say we have a bug on our hands. So let me go ahead and check my recording. Recording was okay, so let's continue. We had a bug. Why did we have a bug? Let's see. we could check the values. The weight, the first weight looks okay, the second weight looks okay. But as you can see here, it's modified this address for some reason. It has copied the RGB values correctly for the first position and for the second position, but for some reason this is 3. Just checking here. Let's stop when we get the bug, and the transparency worked there, but the last weight seemed to be premature. That bothers me. Probably says 03 in the copper list. Of course we need to set the original color from the logo palette after the last weight. So the problem we're having is that our lists are too short, so that this value right here, 833, should be added to our lists. Am I doing the right thing here? Let's see. We need to add 2 values, right, for each scanline. So after the last weight there, it should reset. Hang on. Does it? Okay. So it so it does this 6 times, right? And previously we just modified the weights so that all was well, and this last one reset the colors at the correct position. So that now we need to reset the colors after the last weight like that. Incidentally, now that we're poking the copper list in the frame loop, whatever values are here are irrelevant. They will be overwritten in the first frame. So we did have a constant here. So by doing this and copying that to our lists, at the end here, we'll remove the thing I wrote there before, and we'll have 2 values at the end, which should always be the same. And we may get an assembly error or not, depending on where we declared this constant. And that should basically be it. I'm going to check for that 03 value. Okay. For prudence, we'll correct that. And we're going to update that and run it. That works fairly well, but it's not exactly what we wanted. As you can see, the fill color is modified correctly, but not the other ones. So what should we do about this? Well, when it's behind, it should copy the colors from the logo to their individual color registers for each of the 6 lines 5+1 lines in the copper bar. And when it's in front, it should replace all 8 colors with the copper shade of the raster bar. So that means essentially we'll just have to set all 8 colors at each raster weight. This time we're in luck because since the logo is not full width, there's plenty of time to change all the color registers. If the logo were full width, we'd have to modify this weight statement. And it's pretty easy to do because any value below 7 here will put the weight at the end of the previous line. Strange as it may sound. You would think you would have to write something like 7FFF here, for example, to put it on the previous line, but that's just not how the hardware works. Any value below 7 here puts it on the previous line. So we may change it to 3, for example. How ironic. And one weird thing is that if you do that, I'm gonna put the 7 value back here for a very special reason, which is quite intricate regarding the raster timing on the Amiga, and that is the background color is present even in the border. On later Amiga modules you can turn the border on and off, but we'll disregard that for now. Because we're coding for Amiga 500, well, OCS, ECS at this time, and up. So that means that if we were to change the background color on the end of the previous line, that would be visible on some displays and in emulators, so that you would get this ugly looking step you would see a raster bar with a 1 pixel step in it, where the step would be at the right edge of the screen. On a TV you would probably not see it, but there are many different displays nowadays, so we'll wait until the first position on the new line and then set the background color, and this ensures that the background color is changed outside the left edge of the screen and it will not have a step in it. Hope that makes sense. So what we need to do here is to poke all the registers, so let's go ahead and do that. And as I said, whatever value is here doesn't matter, so we might as well put a 0 here now. That's 5, 6, 7, 8. 2, 4, 6, 8, A, C, E. Oops, a bit too fast. Like that. So we will replace this single color change with a color change for all colors. You can do this with Control Delete, however I haven't turned off my auto hotkey script, so I'm doing it with Control D and Control F. That was the final one. So this will change the logo palette on each line for these 6 raster lines. And whatever values we poke in here will decide how the illusion looks. So what do we say? Well, we said that when it's behind, it should replace all colors except the background color with that semi-transparent color, and when it's in front it should replace all of them with the value from the in front list. So that means that whatever value is in either list should go not only to color 02, but to all colors, from color 01 to color 07, all those registers, which changes the code a bit and of course affects the step. So previously we had 3 instructions. Now we have, instead of 1 extra color, we have 7 extra colors, so that we should add 6 to this. Let's go ahead and double check so that we don't get a rogue copper list again. So this should be 9 instructions. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the step is correct, which means we'll poke in the correct place in the copper list. And instead of doing this, we shall copy it to a data register, and then copy that data register to several, not consecutive, but several places offset from A0. So we'll do this one first. Comment alignment is important. So did you see what I did there? I split that instruction that looked like this into 2 instructions. First I fetch from the list, and then I poke, and this will only change the first instruction. So we can go ahead and test that. And my little space key. I think I have a missing spring under it. Too lazy to fix. So this should be a straight up replacement with a heavier copper list, changing the whole palette here. And the other colors of the logo should be black because it says 0 as RGB value here. So we'll go ahead and update and check our predictions. Well, obviously the step is wrong or something because we're invading the bitplane pointer instructions somehow. Let's go ahead and, first of all, we did check that, and why is it not correct? I do recommend to use the monitor like this, and also use the debugger. Get an ASM1 version that where the debugger works on your flavor of Amiga, because it's a great help to check things. 7C07, then we poke 2 values, it seems. The other color values are left unchanged, and then we get a strange, oh, we're using the data register that is used for the loop counter, or the vertical position. That's not good. Haha. So that's the conflict. So just use D2 instead, supposing it happens to be free or available, and that should look more like it. Yeah. So my prediction was initially wrong, but it's now vindicated. So what remains is to copy this D2 value to the other palette copper instructions so that the logo doesn't turn black. So this is still correct. The background color should still go only to the background color Here, however, we should copy 7 times. So we can make a formula for this. 6 plus 4 times 1, for example, because this was at offset 6, so that this is at the copper instruction following it. And then it becomes easier to make these 7 pokes. So 1, 2, 3, 4, 5, 6, 7, which pokes color registers 1 through 7 inclusive. And this was to fix the problem where the colors used for anti-aliasing and the outline and so on were not being modified, so that the bar was sort of, well, the outline of the logo was sort of always in front of the copper bar. Well, it's certainly not perfect. Let's see, when it's moving, that's not correct. So well, obviously the problem is the colors after the last line of the copper bar, when we are restoring the colors to the logo colors below the copper bar to restore things to normal, so that we can see the logo in its full glory. So that for the last, at weight RAS 6, then the color values should be copied from the logo pel. So we have to make an exception for that, and we can do that by putting in another runtime conditional to check if we're at weight RAS 6 or something, and if so, that will then copy the original values from the logo palette. Also, actually, when it's behind, it should also do that, because after all, when it's behind, it's behind. So it should only replace all the colors when the copper bar is in front. We could do this in several ways. We could make huge lists. We could make one list with instead of 2 colors per line here, we could make 8 colors right here. Just copy the RGB values from logo pal down there. Or we could make a runtime exception. The former solution would take a little bit more memory, a few words more of memory. The other solution would require to write code that must work and not have bugs in it, and also will take raster time. So since raster time is a commodity not easily spent, or actually it's easily spent on slow CPUs. So anyway, since raster time is precious on 7 MHz processors, we shall opt for the former. So we'll space this out and copy some values. So that when it's in front, we can do it like this. 0, 1, 2, 3, 4, 5, 6, 7. I could probably invent a nursery rhyme for that, and that's not good. We have to 1, 2, 3, 4, 5, 6, 7. I'm sorry, 0, 1, 2, 7. And again. There you go. And likewise here. And this then, the final one, should have its colors copied from the logo palette at all times, whether we're in front or behind. Let's copy those. I like text editing. It's like Tetris, sort of moving stuff around. So if you want, you can press enter here and remove the comma, but for now I'm just removing the crop instructions from this, so that it becomes RGB values, pure RGB values. So let's copy that to the last position here when we're behind. And when we're behind, let's see what should happen here. Well, the problem we had was, well, then it should change only the fill color, right? So these values then, hang on, we have color 0, color 1, color 2, 3, 4, 5, 6, 7, 8. That's not right. So which one should go away? Oh, right. Cause, haha, we messed up. We did change color 02 before, so that we need to stick that in when we do these colors. So there should be a color 01 in between these lines right here. Good to keep in mind, so that this 833, hang on, that should be there, of course. And here it doesn't matter because all the color values are set to the same value, except here. But we should remove this. So there you go, the last one is correct. And now we just copy the logo palette, except the background color, to here, and remove this color 02 value, and put it in here. Let's go ahead and do that for all of them. There you go. And whatever is here, 947, should go here. I mean, I could have written a piece of code to do this for me, but, you know, rest of time. Rest of time is rest of time. 859. 947. All good children go to heaven. No, what am I saying? All good coders go to heaven. That's already correct. And this is correct because we didn't copy that. So that should be all right. And this should be all right. And now what we need to do is, instead of duplicating, we should copy these values verbatim. Look it up. So anyway, so that means we can replace D2 from, note that you should not modify this line because it sets the background color, which is what we want to change to make the copper bar happen. From this line on, we can replace all D2 with A2 plus, like that. Yes, 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 yes. Last. L for last. And that really should be it. Let's check it out. Doesn't that look good? I mean, the movement leaves a little to be desired, but I thought I wouldn't get into sign tables and such. If you think you know a little bit about sign tables, you can modify the movement of this copper bar to move well, accelerate and decelerate to make it look like it's making a circle around the logo. Maybe I'll change my mind and add the sign table. But for now, that's your transparent copper bar effect in front of behind and behind for the logo. So, see you in the next tutorial.